Hi, welcome to the channel again. And we just now heard in the intro music, handshaking, something in your mind not right, right? And we have all went through that in a maths class, right? Where your hand shaking, probably you had to go on the board and write something, or in an exam, or the teacher is teaching this maths concept and something not right in the head, you're not understanding it. That is the purpose of these lessons on the channel, to bring clarity, understanding to certain concepts so that we move away from looking at something online and just solutions are being given to you or in a booklet with solutions and you're learning off solutions. We want to move away from that and understand concepts, understand how to work the concept. So when CXC brings a question, and you have to apply yourself, it becomes secondary. You could handle the question, right? So today's lesson is on one of your the topics in your Csec Mathematics, which is question 9 in section 2, paper 2. What we see on the slide, right, is under the topic trigonometry and geometry, and is angular elevation and pressure. And I always have students, and I'm always seeing some memes and thing on Facebook saying that today I haven't used Pythagoras' theorem in my life, but what I'm going to do with these lessons is with most of the concept in the C6 syllabus, I'm going to show you application of it in your daily lives, right? So with angular elevation and pressure, we're going to see how you could apply that in your daily lives or look for those things, right? Or which occupation uses this concept, right? So the objective of today's lesson is to define angular elevation and depression using diagrams, then do a sample question from your CSEC past papers for angular elevation, same thing for angular depression, and then look at the application of this concept in our daily lives, right? So this slide here is showing you, normally when I do an angle of elevations with my students, I will tell them, read your question and do a sketch. No ruler and any kind of equipment, just your pencil and just sketch what you're reading into a diagram, right? So what we see in any sketch is a tree with a birdhouse. A person is walking on level ground and they elevate their head to look at the top of the birdhouse, right? So with they, right, if they was walking straight towards the tree, their eyes would have been parallel to the ground. So that is the horizontal. That is the horizontal line. But from the time they move from that horizontal, their eyes upwards. So look at the top of the birdhouse there. Then their head was elevated, their eyes was elevated, and their line of sight now changed from being parallel to the ground to an elevated position. And normally, when my students draw the sketch, I tell them locate a triangle inside it because angle of elevation and depression is application to Pythagoras' theorem and the trigonometric ratios, which is prior topics to the angle elevation and depression. Right? So from the diagram, the sketch is seeing how they could get a diagram, a right angle triangle, to use for calculation. And you're seeing the vertical part, the height of the tree, the horizontal part, the distance the man is from the tree, and you're seeing an angle of elevation. So this slide is really for us to understand what is angular elevation. That is the angle that the head or the eyes of the person move to look at something above them, right? And you're seeing it at the bottom of the screen. Angle of elevation is always between two lines, the horizontal and the line of sight. So now what we're going to do is look at a question that will come in CSEC pertaining to this, right? So the question is the angle of elevation of the top of a vertical tree from a man standing on level ground 25 meters from the base of the tree is 38.5 degrees. Calculate the height of the tree to the nearest meter. So reading that angle of elevation, so what they're talking about here, a vertical tree, they're talking about a man, just like the example what we had previously, right? So the students will draw a tree draw the man away from the tree, looking horizontal towards the tree, and then raise his head to look at the top of the tree. So you see in the sketch there, and we've seen how we could get a right angle triangle from that there. Once we get our diagram with the right angle triangle and we label properly, like in this case, the height of the tree, um, the distance the person is from the base of the tree, and we put in the line of sight, and we put correctly where's the angle of elevation, which is always between your line of sight and the horizontal. Then you could follow these steps here. Label your triangle with respect to the angle given. So that is the angular elevation. So opposite to the 8.5, that side, that vertical line, is the height of the tree. That'll be the opposite side. Opposite your 90 degrees is always the hypotenuse from your prior topics with Pythagoras' theorem and your trig ratios. And the last side of that triangle is the adjacent to the angle to the 8.5. And the second thing you'll do is circle the dimensions that they give you. And the dimensions that they give us in this question is the 25 meters, the distance the person is from the base of the tree, right? And we circle what we have to get. We have to get the height of the tree. So that is why you're seeing on the screen, we circle opposite and adjacent. And then we would choose the trig ratio, and the trig ratio that has opposite side and adjacent side is tangent. So tan theta, opposite over adjacent, we substitute the values that we have in the question, and we make height of the tree, which is the opposite side, the subject, and we solve. And then we got 20 meters for the height of the tree, right? So far, we know that angular elevation is the angle between two lines, line of sight. That is how you're elevating your eyes and your head, and the horizontal, the ground, right? And we understand how we could apply your trig ratios and Pythagoras' theorem, the concepts before this angle elevation expression to do the calculation, right? Angle of depression is the opposite angle of elevation, where you're depressing the head and the eyes. So if you look at the sketch there, you have a man on top of the cliff looking at a boat, and if he is looking straight ahead, that is the horizontal, where his eyes will be parallel to the sea or the ocean there, right? And if he depresses his head, he would see the boat, right? So we see in the horizontal, the line of sight there, and you're seeing two triangles. Now, when I teaching this to my students, I ask them which of the two triangles, the right angle triangles, is seeing there that CXC, which one you would use in your calculation. And most of them will tell me triangle 2, right? Because they see the angle of depression connected to triangle 2. But you're seeing the distance from the boat straight up to the horizontal. CXC will never give you that distance. That is the distance from the boat to heaven. They will never give you that. So it's triangle 1 you will have to use, where they could give you the height of the cliff, the distance the boat is from the base of the cliff. So therefore you'll be using triangle 1, but you'll be transferring the angle of depression to that triangle number 1, right? And if you look at the diagram that we'll use for calculation, you would see that we transfer that angle of depression, we saw the Z, to the diagram that we use in triangle 1. And we call that angle in the diagram triangle 1 alternate angle to the angle of depression, right? So in CXC, the examiner would want to see in your diagram where is the angle of depression. And some students just lose marks because they forget that top piece there with horizontal there, and they put the angle, the alternate angle of depression as the angle of depression. But no, that is the alternate angle. Angle of depression is above there where we see it in the original sketch and in the diagram there, right? So you always have a 1.5 triangle with your diagram for this calculation. And again, angle of depression is always between two lines. So is it two lines? Line of sight and horizontal, right? So With the angle of elevation diagram is straightforward. You're not transferring any angles. But with your angle of depression, you are transferring an angle. From the angle of depression, you look for a Z, you look for your alternate angle, and you transfer that into the triangle that you're going to use it. Right? The question for angle of depression, let's read it there together. A girl 1 meter in height standing on top of a vertical building 45 meters high sees a car some distance away when the angle of depression is 55 degrees. What distance is the car from the base of the building? So we hear a girl standing on top of a building and a car. So we put in our diagram, you see in your building there, you see the girl on top of it, and you see the car away from the building. So the girl will depress her head and look at the car, right? Now, when we pull out our triangle and a half, you see it there in the diagram for calculation, we know that that vertical line to the horizontal line there is 46 and not 45 because we add the girl's height, the 1 meter, right? And again, guidelines to solve this, you will insert your alternate angle to the angle of depression. You see the 55, we bring it down there in that triangle. We label the triangle with respect to the alternate angle, opposite, adjacent, hypotenuse. Circle again your dimensions that you have and what you need, and then use your trigonometric ratio, substitute and solve. So again, the trig ratio that we'll use is tan. So we put down our equation, we substitute, and we see that the distance the car is from the base of the building is 32.2 meters. All right. So how is angular elevation and depression, where we see that in our daily lives, who will be using it? It will be like it will be like TNTech sports complex putting up a flagpole or a crane operator, right? These people here will have to look at a certain point on the level ground, turn up a laser to the pole, make sure that the wire is anchoring those poles and keeping it stable from earth movements and also wind, right? So these are just a few applications because you might study it. You probably study it already in school, Form 3 and Form 4 and so on. And then you never really think about what's the application of this. If you look at this diagram, this is somebody who's interested in radio, signaling, and so on. So a lot of antennas. And to anchor or to make sure that the antenna remains vertical, he would have to pull wires from a point on the pole that the antenna is on to a flat location and anchor that. And you're seeing it there. So you're seeing the line of sight from the ground, right, on his decking, and you're seeing the angle of elevation between the line of sight and the horizontal. And you're seeing the height of the antenna there, where he put his wire to the ground. So you're seeing he would have to undergo and look at certain things and see where to put that wire, where to anchor it by using the knowledge of angle of elevation, right? The next one is a crane operator. They would have to just seated in that little white area there with the glass, and they will be looking down to the container to see where the crane is, the attachment that to pick up the container, where to drop that attachment to grab the container and lift it and move it. So again, they will be depressing their head, controlling certain levers in the machine there to lower, to move to the right or to the left, and then engage the container and pick it up. Right? So that is an application of angular depression, while the one with the antenna was angular elevation. The antenna poles outside in your house, in your community, you would see cables um, on various sides of it connected to the land, right? That there again also is angle of elevation, right? So at least we understood today, right, partially, what is angular elevation and depression. Elevation is elevating your head or your line of sight. Depression is depressing your head or your line of sight. And we understand where it will be in a diagram between two lines, your line of sight and your horizontal. And this comes after certain concepts like Pythagoras' theorem and trig ratios, where you would have to um, do that concept in order to do the angular elevation and depression, because angle of elevation and depression is application to your trig ratios, right? So what you're seeing here now is the basic outline of concepts for your paper two, right? Your paper two is a structured paper where you have 10 questions to do. Section 1 has 7 questions, Section 2 has 3 questions. And the basic outline or the topics of questions in Section 1, you see it there: computation, algebra, consumer arithmetic, geometry, measurement, transformation, statistics, and investigation. And Section 2, 3 questions, that is your long answer one there, big mark question. Question 8, algebra, relations, function and graphs, trigonometry and geometry. And under trigonometry and geometry, you see, I put some topics there, subtopics: Pythagoras' theorem, trig ratios, and you see today's lesson: angle, elevation, depression, then bearings, and so on. And then question 10 is vectors and matrices. So if it is that you want to move away from just learning off a solution, or you see a exam has finished and a paper and then solutions have come to you and you just want to watch the solution. Oh, let us try to go back to the days now where you could actually take a concept and we could understand it fully to apply ourselves in CXC, right? And in life to see, I will try, if it is in any one of my maths classes, I will try my best with all of these topics to show you real life applications of these concepts. So you'll say, you will never use this statement again or phrase. You went through the whole high school and mathematics and you are using it. No, I will show you it where you will be, you could use it if you choose to, or you could observe an occupation that is using it, right? So if you have learned anything today and you appreciate in terms of seeing a topic in the C6 syllabus and the application in the real world, you always call the 739-3230 number and join either our Form 1 to Form 3 class, the NCSC classes, or Csec Mathematics, Form 4, Form 5, right? And our September registration is open right now, so you could, now's a good time to call. We have started back syllabus in all of these subjects in July, and we'll be continuing that for September onwards, right? So until next time, take care, right? God bless.